Today's lesson is on the review of gas laws. The first one is Boyles Law, and that equation states pressure 1 times volume 1 equals pressure 2 times volume 2. Basically what it's saying, as volume increases, the pressure decreases, and vice versa. Let's take a look at one of those examples. Let's say we have a balloon, and we know if we got particles, air particles within inside a balloon, because of the kinetic energy that's in those particles, they're randomly bouncing inside that balloon, causing force to be exerted on the inside of the balloon. As that force exerts its energy, that would be referred to as pressure. If we were to decrease that volume, we have the same, obviously because of standard temperature and pressure, have the same number of particles in there, but they're going to hit the sides more frequently because there's less space. And because there's less space, more force is exerted on the inside part of the balloon. And because of that, more pressure. So pressure and volume in Boyles Law is inversely proportionate. So what we're going to do is, let's take a look at this problem. Actually, these problems are relatively simple. You just got to understand what they're asking for and then plug them in. The PV1 equals PV2. So a sample of carbon dioxide occupies a volume of 3.5 liters at 125 kilopascals of pressure. What pressure would the gas exert if the volume was decreased to 2 liters? So let's look at that problem. One of the first things you're going to have to do is you have to change this equation up a little bit, using a little bit of just simple algebra. And what we're really looking for, that's the first thing you've got to kind of surmise when you're looking at these, breaking down these problems. What pressure would the gas be? So we're looking for, here's P1. Oops, P1's over here. V1 is over here, and V2 is over there. So with that in mind, what we're going to have to do is we're going to have to kind of rearrange this. So in order to get the P2 by itself, you're going to have to divide this side by V2. Anything you do on this side, you're going to do on this side as well. So you're going to do the same thing over here. And these will cross out. So the equation you're really working with here is P1 times V1 divided by V2 equals P2. So now we got it all set up. Let's go ahead and kind of plug in the numbers. So in this case, P1 is what? Well, right here, 125 kPa. So we're going to go ahead and put that in there, 125 kPa, and let's put parentheses on so we can keep track of it. The volume on our first case scenario here is 3.50 liters, so I'm going to put that in. Notice I've put the units too, because units really do help you kind of figure out what it is you're going to be trying to solve for. I'm going to divide this all by the volume, V2, which is 2 liters. So I'm going to put 2 liters, 2 points, I'm sorry. I'll just put 2 liters. Should be 2.00 liters. And then all of these, the liters will cross out. So what we'll have left in units is kPa. And if we were to multiply these two together, let me go ahead and do that right now. It's 125 times 3.5, and that's going to equal 437.5 divided by 2. And we divide that by 2, and we're going to get 218.75 kilopascals. But we have to take a look at our significant digits, and we'll notice in this case there's 3, so we're going to round this up to 219 kPa. Now, how do we know that's right? Well, we know from what we studied on Boyles Law, if pressure goes up, what does volume do? It goes down. So in this particular case, let's take a look. We saw the volume go down, so what should happen to the pressure? The pressure should go up. So if we take a look, Our final pressure was 219, and up here this was 125. So it definitely checked as far as the law is concerned. So when volume went down, pressure went up. So that's our first problem. Let's go ahead and do one more. Let's change it up a little bit and look for something different on problem number 2. A 2-liter container of hydrogen had a pressure of 3.2 atmospheres. What would be the volume necessary to decrease the pressure to 1.0 atmosphere? So in this particular case, what we're doing is we're changing the pressure. So we're actually looking for volume. So again, if we take a look at our problem, P times V1 equals P times V2. On this particular case, we're going to look for volume. We want volume here. So we're going to put this down here because we're going to have to get rid of P2. So in order to do that, we have to divide that by P2, and the same thing over here, divide that by P2. So it looks something like this. P1 times V1, and that equals, now remember, we're getting rid of the pressure, so we're going to put the pressure down here, P2, and that's going to equal V2. That's what our volume is going to be. So we know that P1, according to this, is going to be 3.2 atmospheres. So here it is right here. So let's just put that in the equation. So P1, it's atmospheres now, 3.2 atmospheres. Now that you can be in torr, you can be millimeters of mercury, you can be atmospheres, you can be kPascals. That's all in pressure. And that kind of helps you with the understanding what units you're going to need this in. Okay, and V2, it means it's going to, excuse me, this should be V1. I made a mistake there. It should be V1. V1 is, I'm going to put parentheses on this, kind of keep track of everything. V1 is 2.0 liters. And we're going to divide it by P2. And the atmosphere is 1. So we have 1 atmosphere. This should be really easy to do. 3.2 times 2 is 6.4, because again, the atmospheres cross off 6.4 liters. So in order for what has to happen to the volume is going to have to be, it says what volume would be necessary to decrease the pressure. So when we look at this volume right here, we can see we have actually increased the volume. So the volume would be 6.4 liters necessary to decrease the pressure to 1 atmosphere. So again, does it check? Well, yeah, because what had to go down? Well, according to this, our pressure went down. As our pressure went down, volume went up. So those are still inversely proportional. I hope this helps. Again, remember, you've got to keep track of what you're solving for, and then just deal with it algebraically. For instance, in this particular case, if we're looking for volume, we would, of course, divide this whole thing by P2, and vice versa. So again, just take a look at the problem, see what it is that they're like, what are they asking for, and that's what you solve for. Simple as that. So until next time, we'll see you later. Thanks.